Okay, welcome to our first SolidWorks simulation FEA tutorial. In this tutorial, we will be going over basic beam deflection and how to set that up. So, first things first, we're gonna make our beam. So this can be any shape you want, as long as it is centered on the origin. So I'm just gonna make a pipe with these dimensions. Okay, you can tailor this to the problem you're dealing with, and yeah, should be fine. Okay, so I'm just gonna make this 2 feet long. Again, you can set this however you want. Okay, so now we've got our part. Now we're gonna FEA it. So if you don't have this simulation tab, go to Tools and then scroll down to Add-ins, and you can click SolidWorks Simulation box. Okay, cool. So now in the Simulation tab, we're going to hit New Study, and you can call this whatever you want. I'm going to call it Beam Deflection. Okay, hit the check. Okay, so now at the top of your screen, you can see we've got a lot of different tools we're going to use for FEA. And in general, we're going to run from left to right, from apply material to run this study. So first things first is we're going to apply a material to our beam. Okay, so I'm going to select the part and then hit apply material. Okay, so SolidWorks has a lot of materials. It will probably have your material. If it doesn't, you can also make custom materials. We may go over that in another tutorial. So I'm going to say this one's 6061 aluminum. So click your material and then hit apply. You can see it's got all your Young's modulus, Poisson's ratio, that kind of stuff in here. And with custom materials, you can set all those yourself. Okay. Okay, so next, we're just gonna go left to right. We're gonna make the fixed geometry. But before we do that, since this is a beam, we're gonna right click it and hit treat as beam, okay? And this will make it into basically a one-dimensional thing that makes it easier to deal with. Okay, there should be 2 little gold spheres at the ends, each end of your beam. Okay, so now we can hit fixed geometry. Okay, you guys should know what fixed geometry does, but there you go. Just click one of the gold spheres, and you can see there's an animation of the fixed geometry there. Okay, hit check. Okay, next we're gonna go to the external loads. Okay, so there's lots of different external loads you can use. There's force, torque, gravity, distributed mass, etc. We're just gonna use force for now. Okay, so there's a couple options here. We're gonna hit joint, which is this middle one. Okay, then we're gonna select our gold sphere. Okay, and then this pink box is our reference frame. So what our reference plane. So what our force is gonna be relative to. And I'm gonna select the top plane for this. Okay, and then I'm going to real quick change the units to pounds, and then select this normal to plane. And you can see now our force is going normal to the top plane. You can also set it to like next to the plane, but for now we're just going to do top plane and hit reverse direction. Okay, I'm going to set this to 100 pounds, and I'm going to hit enter. Okay, so you can of course tailor this to your problem, but for now this is just demonstrating the tools. Okay, I'm going to hit check there, and it should say 100 pounds on your force there. Cool. So now there's no connections because we've only got one part, and we can just hit run study. So let's see if we can splice this. Okay. So as you can see, we've got the stress component shown and the displacement. So what I like to do is go in here and hit the stress plot. So I double click that. I'm going to change the units to PSI because I generally prefer that. And then over in chart options, I also like to hit show min and max. And if I hit check here, now we can see the max stress is over here at where we fixed it to the wall, and the minimum stress is over by the force. That makes sense. Okay, so to view the, also if you want to like view the stress at any point, you can go over to plot tools and then hit probe, and then just click wherever, and it will tell you the stress at that point. Okay, now you can also look at the displacement. Just double click that. I'm going to double click it again to get back to editing this. I'm going to change it to inches, go over here and show min and max. Okay, so this also makes sense, right? Our max displacement should be over where the force is and not where it's fixed to the wall. So we're all good on that front. And our max displacement is about 0.7 inches, which makes sense. So yeah, that is how you run a basic beam deflection study in SolidWorks simulation.